So for example 3, the job, you see it talks about filling a swimming pool, and then it talks about emptying a swimming pool. And then the question is, how long would it take to fill the pool? So we're going to call this one our job, quote, quote. So to fill the job, to fill the pool, the pipe can do it in 20 hours. So it does one job of filling the pool in 20 hours. Now the outlet pipe can empty it, which is unfilling it. So it's going the opposite direction. So it's going a negative direction, and it does it one job in 32 hours. So it kind of like goes in reverse, one job in 32 hours. So if these two pipes are working, starting at this, both turned on, or, one's open and one's filling and one's emptying all at the same time, then they're both x's, and we get x over 20. We get a negative x over 32, and we want to know how long will it take to do one job. So our equation will be x over 20 minus x over 32 is equal to 1. And I will not work that problem. Okay, let's skip over to example 6 and figure out if f of x is equal to x over x plus 3, what is f of x? So I'm going to write that underneath it. I'm going to have f of x. So that means that I'm going to take f of x and I'm going to plug it in for the x every time I see it. So that means I'm going to take f of x, and then it's going to be over f of x plus 3. So replace the x's with the f of x. That looks really funny. Of f of x. So now what is f of x? Well, f of x is x over x plus 3. So I'm going to have x divided by x plus 3 all over x plus 3. And then I've got plus 3. So replace my f of x's with x over x plus 3. So now that is a complex fraction, which I'm going to solve by multiplying by the clever one, x plus 3 over x plus 3. So remember, that's my common denominator for those fractions. So when I multiply times my numerator, the x plus 3's cancel, and I get x. When I distribute it times the denominator, the x plus 3's cancel here, and I get x. And then when I multiply it times the 3, I'm going to have 3. So plus 3 times x plus 3. So that's going to be equal to x over x plus 3x plus 9, which is equal to x over 4x plus 9. And that is my answer. Okay, now we're going to skip all the way to the end and take a look at example 8. So read through this, try to set up a chart, and then check back with me. All right, so here it is. I've got my rate, kilometers per hour times hours is equal to kilometers. And sounds like there's a slow time and a fast time. So I wrote those down. So now let's fill the chart in with the numbers. So the first thing I noticed, it said 280 kilometers. So underneath kilometers, I had this guy go. He traveled 280 kilometers at a certain speed. We don't know what that speed was, so I called it x. If the speed had been increased by 5 miles per hour, so that's the faster one, x plus 5, the trip could have been made in 1 hour less time. So he traveled the same amount, so he's going to go the same trip, 280 kilometers for both of those. All right, so now we're used to having these two things. This column times the second column equals the last one. So what if I have the last one given to me? How do I find the middle one? I hope you're thinking this right. You're going to take this, divide it by your x, and it's going to tell me how many hours that is. So I'm going to take the 280 and divide it by x, and that will represent how many hours. And then also here, 280 divided by x plus 5 tells me how many hours it took them on the fast speed. Now, it said the trip could have been made in 1 hour less time. So the faster speed is going to take them less time. So we might say that the fast speed, the fast time, plus 1 hour, and I'll call that hour, is going to be equal to the slow time. So slow hours. So I'm going to come up with the fast time is 280 over x plus 5 plus 1 is equal to the slow time, which is 280 over x. Now we're going to do a little bit of algebra and get rid of this. So LCD is going to be x and x plus 5. I'm going to distribute it to everything. So when I multiply times the first term, the x plus 5s are going to cancel. And I'm going to have 280x. Times the 1, nothing cancels, so I'm just going to distribute it and put x squared plus 5x. And then times the last term, the x's cancel, so I'm going to get 280 times, I'll write it out, x plus 5. So this will be 280x plus x squared plus 5x is equal to 280x plus big number, 0, carrier 4, 44, carrier 4, 14. All right, so now I see an x squared. So if I have an x squared, that means I need to move all my terms to one side. So we'll put our x squared first. We're going to have, I'll put it plus 285x, then subtract 280x, and subtract 1,440. And I'm left with just what I want, a 0 on the right side. So let's combine like terms, and I get x squared plus 5x minus 1,440 is equal to 0. And oh my goodness, 1,440, we're going to have to look for some factors. So I start off with 10. I'll come over here with 10 and 144, which I know is not going to be right. It needs to be negative. So one of these is negative, and that doesn't work. So then you might ask yourself, does 20 go into it? And my guess is yes. So bring out your trusty little calculator and see if 20 goes into it, and then we'll try a few more things. Okay, confession. Hopefully you caught it, but I just now caught it when I couldn't find anything that worked. So this is going to be 14. When I multiply 5 times 280, I shouldn't have done this in my head, should I? I get 1,400 instead of 1,440. And so scratch that out. Basically repeat the same thing, and you're going to come up with that 40 goes into it 35 times. And so on this, we're going to then, we want our 40 to be positive and our 35 negative. So this is going to factor into x plus 40 and x minus 35. So I get x plus 40 is 0, x minus 35 is 0, so x is 35, x is negative 40, can't be negative, so our answer that we're going to come up with is 35. So he drove at a slow speed of 35 and a faster speed of 40. So his actual speed then that we're looking for is the 35 kilometers per hour. All right, so let me fix the rest of this. This should be 1,400, and that should be 1,400. The end.